Here's part 2 of our calculus summer survey. These are questions number 4 through 7, or the second page. So starting with number 4, we see that you have a function of x with respect to time, and I want to find all the values of t for which x prime of t is equal to 0. So first, I need to find x prime of t. So just like in the previous questions, I'm going to start with my original function, and I'm going to apply my simple derivative rules to each term. So x prime of t will be taking this 3, using it, making it a coefficient, leaving the negative there. I am left with negative 3 times x to the now second as I reduce that power for the first term. For the second term, I'm bringing the 2 down. I'm going to go ahead and multiply 2 by 2, which is 4. And I'm going to reduce this 2 down to a power of 1. And then for the third term, I have a power of 1. So this is 3. And now that power of 1 becomes a 0, so my x term vanishes. So here is my x prime of t function. I want to know when this function is equal to 0. So I'm going to set it equal to 0. So you may be aware that this is a quadratic equation, as you can see by the square. So a couple ways to solve this. I used Wolfram Alpha. If you have access to a computer, Wolfram is a very quick way to do this. Type it in, it knows how to do this. This gives back to me results of, for one time, 0.53518, and for another, negative 1.8685. So not very pretty, but that is the answer. Moving on to number 5. Again, I'm looking for a derivative. So I want dy dx, and here is my y function. So I want to use the quotient rule in this particular problem because I have a fraction that I want to take the derivative of. So if you remember from the summer work, it's low d high minus high d low over low low. So how does that turn into this? Well, here's high, here's low. So low will be 1 minus 3x squared. Forgive me, here's my y prime. So that's low times d high, which is the derivative of the top. So the derivative of 2x is simply 2, because I take the power of 1, multiply by 1, reduce this power by 1, so it becomes 0. X to the 0 is 1, leaves me just 2. So I have low d high minus high, which is 2x, d low. And the derivative of my lower half of the fraction is taking the 2 down. So I have negative 6. And my x squared becomes x. Now this is all over low, low. So low times low is really just the square of the bottom of my fraction. So if you left it like this, that's okay. But we can do a little better quite easily. I'm going to simplify this top bit by multiplying and distributing. So I have 2 minus 6x squared for the left-hand side. And on the right-hand side, I have a negative 2x times negative 6x. So that is positive 12x squared. So I can collect a few terms here. Don't forget I still have a denominator. And this gives me in the end positive 6x squared plus 2 over 1 minus 3x squared squared. And if you leave it like this, that's perfectly fine. Moving on to 6. So I want to find the derivative of this, and now we have a trig function, and it actually involves the chain rule as well. So if y is 2 sine of 2 pi x, the first thing I want to do is take the derivative of the exterior. So how do I do that? The derivative of a sine function is simply cosine. So I'm going to leave this coefficient of 2 out front. Derivative of sine of x is cosine of x, so my sine becomes a cosine. And the argument for that remains the same. So my 2 pi of x that is inside my sine stays the same. So I have 2 pi x. But I need to take the derivative of this argument as the interior. So the derivative of 2 pi x is simply 2 pi. So this then can simplify to 4 pi times the cosine of 2 pi x. For question 7, I want to find the derivative of this nasty looking thing. So this is not too difficult, but it certainly looks that way. So my function, 5 to the x squared minus 3x plus 1, can actually be simplified a little bit if I wanted to use natural logs. Now, if you actually look in your summer work, you can see that there is a formula for taking the derivative of something of this form, y equals a to the x. So if we actually follow that formula, we end up with something that looks like this. So a in this case is 5. So the first part of my derivative will be simply the same function I was given. So that's in parentheses, we'll say. Then the second part is the natural log of a, then the derivative of this power. So my x squared becomes 2x, and my negative 3x term becomes simply negative 3. And if you leave it just like this, that is a perfectly acceptable answer.